So hi everyone, welcome back to our channel, and today we will learn how to identify patterns of binary search. So without wasting any time, let's start. Most people think binary search is about finding an element in a sorted array. But that's not true. Binary search is not only about searching. It is about eliminating half of the search space by using the logic. Or you can say it is a searching algorithm which reduces the time complexity from O of n to O of log n by eliminating half part in every iteration. So in this video, I will teach you how to identify binary search and will teach you 4 patterns that cover mostly all interview asked questions. So before going forward, you need to remember 2 things here. First, if you are sitting at the mid and you can decide whether to go left side or to go right side, then you can think of binary search here. Or else it is sorted. Whether it is fully sorted or partially sorted, still you can think of binary search here. Now let's begin with the first pattern, which is called basic binary search. And this pattern is very simple. In this, simply you will be given a sorted array and you will be given an element, suppose 8, and your task is to check if that 8 element present in that sorted array or not. So here you can think of binary search. So in binary search, you need to follow few steps. First is you have to initialize your left pointer and you have to initialize your right pointer. So left pointer you always tend to initialize from the 0th index and right pointer you always keep at the last index. And instead of linearly searching in the entire array, you actually go and picks any mid element from this array. So basically you calculate the mid index for this. And for that, we all are very used to do left plus right divide by 2. So if considering this as the 0 based indexing, so right is pointing to 3rd index and left is pointing to 0 index. So 0 plus 3 by 2, which is 1.5, means 1. So here we will consider 8 as the middle element. And in this, the middle element itself is the target. If suppose our target was 12, so in this case, we can decide whether 12 lies in the right half part or left half part, and that we will decide on the mid element. We will simply compare our target value 12 with the mid element 8, and we will say ki, hey, this 12 element lies in the right half of the subpart. And here we will move our left pointer from 0 index to mid plus 1. And then we will continue searching in the right half part of the array, eliminating the left half. And here the mid calculation also have a logic. Instead of calculating left plus right by 2, we prefer not doing this. Instead, we go for left plus right minus left by 2. Suppose right is a very big number, somewhere around infinity. Then if you will do left plus right by 2, so a right number which is almost infinity, if you are adding a single 1 also, that will go out of bound and it will make it negative. So you cannot find the right index in that case. Hence we go with this, ki even if right is infinity, we will subtract some left part, and hence that will make it a smaller number. And then dividing by 2 will make it more smaller, and then adding the left pointer is almost safer. So let's take an example here. In case of right, suppose right is 100, and just imagine beyond 100 number does not exist. So if you go adding 100 plus 1 also, that will go out of bound. And so we use this formula. So if right is 100 and suppose left is 1, so if we are subtracting and dividing it by 2, it is somewhere around 99 by 2. Can we say 49.5? Yes, we can. And then in this 49.5, we will add this plus 1, and hence it will make 50.5. So this also gave me 50.5, and if we had used that formula left plus right by 2, as left plus right by 2 will also give you 100 plus 1 by 2 means 50.5. But because beyond 100 the number does not exist, so adding a single number also will give you the error, and hence left plus right minus left by 2 gives you the safer mid index. So remember this point in the interview. Now another very important concept where mostly coders get confused. First is when to use while low less than equal to high or while low less than high. Always remember, when your value exactly present in that sorted array, then you go with low less than equal to high. And when your answer does not exactly present, basically you search with a boundary condition, then you go with the second option. And we use this while loop mostly in binary search on answer pattern, which we will see in the same video. So this was the first pattern where you can practice questions like search in a rotated sorted array, find insert position, square root of x, etc. Now the second most important pattern is lower bound and upper bound. Here also the array is sorted, but remember it is sorted in two parts, and hence it is nothing but k times rotated sorted array, because initially this array was sorted only, but after one time rotation this 6 moved from right and it came to left. After second rotation this 5 moved from right and came to front. After third rotation this 4 moved from right and came to front, and hence this array is nothing but the exactly matching with the input array, and hence it was sorted only, but in two half parts. 4, 5, 6 is half sorted array and 1, 2, 3 is also sorted array, both in ascending order. So can we apply binary search here? Yes, we can apply, but the normal binary search fails here. Let's see how. Suppose your task is to find 1 in this array. So what you will do, you will initialize your left and right pointer from here, and now you will calculate the mid index. So mid will be 2 here. Now 2 means this 6, because this is 0 base indexing, so 6. Now, as per the normal binary search, what will you do? You will search with your target and mid. You will compare with 6 and 1, because binary search is only applied in the sorted one. So you can say that this 1 would have lied in the left part of the sorted array. And then what you will do? You will move your right pointer from here to mid minus 1. And now you will start searching 1 in this left half part. And hence 1 is not present here and you will return false, because you have not found 1 here. But this is wrong, because 1 was there in the right half of the sorted array. So hence here in this case we apply binary search, but first we filter out which part is sorted. How we filter out? When we found mid here, we will first check with left and then we will check with right to find where the mid exists. The mid lies in the left sorted part or right sorted part. How we will check? We will just compare if mid is the part of the left sorted array, then for sure this mid will be greater than this left. So we will check if array of left is lesser than array of mid, then we can say that mid is a part of the left sorted, and if it is a part of left sorted, then we can simply go and apply the binary search here. Only when this one lies in this range, and that range we can simply search with left and mid. So here after this we will check if target lies between array of left and array of mid, then we will go and apply binary search in the left half. But in this case it is not true, so hence we will go and check in the right half of the sorted part. So first thing is we will apply binary search, but only when we will check where our mid lies. Mid is a part of left half sorted or right half sorted. Now when to apply this pattern, and this is not basic binary search. We apply binary search, but after that mid check. And we will apply this pattern only when the sorted array is rotated sorted array. Second, if that sorted array contains duplicates. Remember, if that contains duplicate, then we will go for this lower and upper bound pattern. And third is, whenever question says give me the first occurrence or last occurrence, you can go with this pattern of binary search. So remember, rotated sorted array is not a special binary search. It is just like we are applying the binary search but in broken parts. And for that broken part, we first check where our mid lies. And basically you search for which side is valid. And if you're able to think that, then you will never get stuck. Now next pattern is binary search on answer, and trust me, this is very, very important from the interview perspective. And here comes the tricky part. You will not be applying the binary search on the given array. No, you will be applying binary search on your answer, and your answer will be lying in a certain range. For example, suppose you're thinking that 5 can be the answer or not. If 5 is the answer, then you might go for the right side or left side, but not linearly. Basically, here also you will applying the binary search. Should I check with 2 now or should I check with 7 now, and so on. Basically, you are applying binary search but on your answer range and not on the given input array. To understand this more clearly, let's move on to the question. So the question says there is a monkey named Coco, and here the array elements indicates that at particular that index how many bananas are there to eat. So Coco will go and eat that bananas. You have to tell what is that minimum speed with what Coco should eat those bananas, such that he will be completing all those bananas within that h is equal to 8 hours. So what you will do, you will simply apply a brute force here and you will say, let's suppose our speed is 4. So if you are going to eat with 4 speed, then this 6 bananas you will be completing in 1 point something hours. So basically you have to wait for the entire integral value. So you will be waiting for 2 hours here. Now here 5. So 5 divided by 4, again 1 point something, again you have to take 2 hours. Now 3 is 0 point something, so you will be waiting just for 1 hour. And this 4 you will be eating in just 1 hour, so 1 hour. So total you took 6 hours, and hence this 6 hour is definitely less than 8 hours. But is this a valid answer? Yes, it is a valid answer, but you can go for a more lesser speed because the question is asking you the minimum speed. So in this case, you have checked with 4. Now you would like to check with 3. If you are checking with 3, there are 6 bananas. So if your speed is 3, for sure you are going to take 2 hours to complete this banana. Similarly, 5 divided by 3 is 1 point something. Again, you will take 2 hours. 3 divided by 3, you will take 1 hour. And 4 divided by 3, you will take 2 hours because it is 1 point something. So total hour is 2 plus 2 plus 2, 6 plus 1, 7. So you are taking 7 hours. Again, it is lesser than 8. It is valid, but it is a valid answer. But is it the minimum answer? To check that, again, you will check with speed is equal to 2. So basically, what are you doing? You are actually calculating the time which you can do in a simple function, but you are applying the binary search on these speed. And that speed you are taking manually, or you can say from a given range which you are deciding. So hence in this type of question where you are applying the binary search not on the input array but on your range answer, this comes under the category of binary search on answer. And for this you can practice questions like allocate books, cocoa eating bananas, and split array largest sum, etc. And don't worry, we will be discussing all these questions in more detail when we will be solving questions around binary search pattern. Now the fourth and last pattern is binary search on a 2D matrix or 2D array. So basically you will be given a sorted matrix, row wise sorted and column wise sorted as well, and you will be given a target value, let's suppose 9, and your task is to apply the binary search and find this element 9 inside the sorted matrix. The brute force approach is you can simply run 2 for loops on every row and then you can manually or linearly check that element is present or not. Second is binary search. How you will apply binary search? First, you will apply binary search on column to get that valid row. Why I'm saying this? Suppose this is 9, and as you know that the matrix is already sorted in row wise as well as the sorted in column wise also. So this next 7 is greater than the last 6, and this guarantees keep that 9 when compared with 6. So 6 can say ki hey 9 you are greater than me, then for sure you won't be lying inside my row. So go to the next row. So 11 will say hey 9 you are lesser than me. So you might be present inside my row if you are present in that matrix, or else if you're not present, you are not present anywhere else. So hence with this concept we can apply the binary search on column first, either the last column or first column based on your condition, and then get the valid row then. And once you get the valid row, then you will be applying the binary search on this row to search that 9 element. So what is the time complexity you took to search that element? First, you applied the binary search on the column. So basically number of row times. So you can say log of row time complexity and then plus, and then you apply the binary search on a valid row. Valid row means number of column times, you can say. Yes. So hence the logarithmic time will be log of c, and log of r plus log of c is nothing but log of r into c. Why I said this? So basically this is not a magic anywhere. We just applied the binary search on the entire row. How we can say? Suppose you will open this. So when you will open this, you will get 2, 3, 5, 6. You open the first row. Now open the second row. Next second row will be 7, 9, 10, 11. Now open the third row. When you will open the third row, it will give you 12, 15, 17 and 18. And when you will see this is nothing but a sorted array itself. Of size what? Nothing but r into c. So basically when it is of size n and you apply the binary concept, it takes log of n time complexity. Similarly, it will take log of r into c time complexity, which is nothing but log of r plus log of c. But remember, here also there are multiple variations which we will be seeing when we will be solving questions around this pattern. So as of now, you can just remember all these patterns we have discussed, and going forward we will be discussing questions on these pattern basis itself. And as I have already structured a pattern wise DSA sheet, and the link is in the description, you can check out for sure. This video was only for thinking, and the sheet is for revising and practicing your DSA problem. And if you actually want to solve problems on your own, you have to remember the patterns for sure. And for that, you need to follow that DSA sheet and do subscribe my channel, because going forward, we will be solving questions all around the patterns itself. So let's meet in another video. Till then, keep learning, take care of yourself and your family too.